Okay, let's go ahead and work on a few more of these. Each of these will use the general power rule in some form or another. Let's see, I need the derivative of g of x, where g of x is this polynomial to the fifth. Well, that's going to equal 5 times, the inside stays the way it was, I'm not going to be messing with it, to the 5 minus 1, that's 4, times, now I need the derivative of the inside. So that's going to be 12x squared minus x to the first plus 3. And then you may or may not want to expand this thing out. It depends what I'm going to be using it for. This x to the fourth, I don't think I want to expand that out. I would definitely leave my answer like that. Okay, this one, the first thing I'm going to do is I'm going to rewrite this, because taking the derivative as it sets is not very obvious. So I'm going to write this as x squared minus 2. Now this is a fractional exponent, so this is raised to the 2/3. Now it's set up so that I can use the general power rule on it. So f prime of x will be equal to 2/3 x squared minus 2. So the 2/3 minus 1, well, I'm going to write that. 2/3 minus 1, obviously that's a negative 1/3, times x squared minus 2 prime. So this will be 2/3 times x squared minus 2 to the negative 1/3 times 2x, which I would definitely rewrite this as 4x over 3 times the cube root of x squared minus 2. And then there's my answer. Okay, this one is really not nowhere near as difficult as it may look. The first thing I'm going to do is I'm going to rewrite this. I am not going to do this with a quotient rule. I'm going to write this as 3 times 2x minus 1 to the negative 2. Now it's set up for the general power rule. So h prime of x will be equal to 3 times the negative 2 times 2x minus 1 to the negative 3. Remember, I'm subtracting 1 from the exponent. Times, I need this inside now, 2x minus 1 prime. So this is going to be negative 6 times 2x minus 1 to the negative 3 times the derivative of this is simply 2x. So yeah, I would definitely rewrite this as negative 12x over 2x minus 1 cubed. And that's my answer for that one.